we have a street light on the pole. The height of the light is 11.5 feet. A man is walking away from the pole. The man has a height of 5.8 feet. We are going to call the distance of the man from the pole x. And we know that the man is walking away with the speed of 6.5 feet per second. So you might ask how I know that this is x prime, which is very important to recognize when you are starting to solve these questions. So there are two ways to get to this conclusion. First of all, I call this x, and that's the distance, and the rate of the change of the distance, which is a speed, so it's gonna be derivative of it. It's dx over dt is x prime. Also, the feet, the over second, it's your other clue that is change over time, so that would be another sign. The question asks for the tip of the shadow of the man when he is walking away, and they want to know how fast it's moving. So if this distance, the tip of the shadow from the pole is called y, we are looking for the y prime when the man is at the distance of 41 feet. So these are all the information we have been given. And make sure that you are calling this distance, or if you are using this distance, at the end you need to add these amount, the horizontal distance of the man from the pole. That's one of the tricky part of this question. So for starting, when, in the implicit differentiation, it's very important for us to find the relationship between these two parameters that we have. So in different question it would be different. In this question it's pretty much obvious. We have two similar triangles and we can use the relationship of the similar triangles, which would give us, so we know from similar triangle that the ratio of the corresponding sides are equal. So I'm gonna write it. We have this big triangle and this smaller one here. So I'm gonna start from this side. Y over in the smaller triangle would be y minus x, and I'm gonna go to these sides. I started with the bigger one, so I'll continue with that. So 11.5 over 5.8. If I solve this for y based on x, I would end up, let me write everything down. I would have 5.8y equals 11.5 y minus x, which would give me at the end, I'm gonna bring the x's here. So I would have 11.5x equals y 11.5 minus 5.8. If I do the minus, I would have 11.5x over here. It gives me 5.7. It's so close, don't think that I made a mistake. So I now have the relationship between y and x, and now I need to make a derivative of this equation. So from the left part, the derivative of y would be y prime, and here these numbers, the height of the man and the pole wouldn't change, so they are fixed, they're constant. So I'm just gonna write these numbers down. It's gonna be the same, and the derivative of the x would be x prime. We already have the x prime, the speed of the man moving, so we end up with, just gonna substitute the numbers that I have, which gives me, oh sorry, is 6.5. 6.5, and that's our final answer. So it's notice that the speed of the tip of the shadow, it's not related to the man's, where man's is standing, the man is standing. So we didn't use the X. So that's another tip at the end of the question. Thanks. Let me know if you have any question. Hope you can use it.